Today we are going to learn 9.3 undetermined coefficient of higher order equations. So undetermined coefficient we heard before, right? So from earlier section we learned that. So this section is about higher order equations. So we're gonna talk about the triple derivative. Yeah. Okay, so let's do this. So last time we have constant coefficient equation. Then we have the left side, this form. And then the right side has f of x. Yeah. Then f is a linear combination of the function of the form. So we have e to the alpha x, then times of p sub 0, p naught, or p naught, plus p sub 1 x plus, and so on. Then the last term will be p sub k times x to the k power. Then left side, like a constant coefficient, right? And then right side, we have f of x, but then we have a new equation for the right-hand side. So we rewrite this way, right? Okay, so let's talk about the linear combination again, right? So we had linear combination. So we have the form of linear combination. So y equal to c sub 1, y sub 1 plus c sub 2, y sub 2. This is from general solution, right? Then we can say that y is a linear combination of y sub 1, y sub 2, or we can this the express curly bracket and then y sub 1, y sub 2, right? Okay, in that case, they say that f is the linear combination of the function of the form and that, right? Then this means f is a linear combination of e to the alpha x because we multiply back everything. Then first term has only the function has e to the alpha x, right? And second term has x, and so on. Every term has e to the alpha x, and then power of x, then x to the k power at the end, right? So we can say that f is a linear combination of e to the alpha x and, right? Not the or, and because we had the form, if we have this form, then y is a linear combination of y sub 1, y sub 2. Yeah. So we do that here too. E to the alpha x and e to the alpha x times x to the n power, right? So n is greater than or equal to 1. Yeah. Okay. Now, for example, if we have f of x equal to 3e to the 2x plus 5x squared, then we can say that f is a linear combination of e to the 2x and x to the second power. If we have this form is similar with that, right? And we can express this one, distribute, then we have e to the x power plus e to the x, yeah? That's why f is linear combination of e to the x and e to the x power times x power. X power? Sorry, x, not the x power, right? Okay, we understand the equation, right? Okay, now, as I told you earlier, so this is from section 5.4, which is the method of undetermined coefficient, constant coefficient. Yeah. Okay. So let me write down. Oh no, not write down. So let me, sorry about that. I don't know why I'm rushing right now. Okay. Let me relax a little bit. Okay. Because this is recall, that's why. All right. So let's review this one. If we have constant coefficient equation, left side, and this is from linear second order, right? Okay, then right side we have e to the alpha x, we call g of x, right? Okay, then in that case, we have a general solution consists of particular solution plus complementary solution, right? Complementary solution. Yeah. Okay. Then we have a table. So g of x. So what's the g of x earlier? We have e to the 2x, right? Then looking at this form, in that case, a equal to 1, right? Because we have e to the 2x, right? Then we are guessing the particular solution, a e to the beta x, 2x, yeah? Okay, but then in that case, if we don't have a solution, yeah, here, if we have a solution e to the 2x, and then the solution is r equal to 2, then we add x there. If we have the same form, left side, in that case, complementary solution, right? Then we add x squared and using e to the 2x. Okay, please review the video 5.4. Yeah. Okay, now let's move on. Look, we have the linear second order equation, left-hand side, and then we called right-hand side g of x. Yeah. So g of x. So we have to check the complementary solution first. If we don't have r equal to 2, then we can use that guessing, which is from the table, a e to the 2x. Yeah, so check that complementary solution here. So we have r equal to 4 and r equal to 3. Then we can use that, right? Yeah. Once again, if r equal to 2, we cannot use this one. So we can use ax, e to the 2x. Yeah. All right. Okay, let's move on. So r equal to 4, r equal to 3 means we have two real distinct solutions, right? So we can have this form as complementary solution. Yeah. Okay, now particular solution from the table. So we guess a e to the 2x with derivative, second derivative, we get that, right? Then from original equation, we substitute what is the y second prime, what is the first prime, what is the equation of y, we substitute everything here, right? So we have, this is y second prime, this is y prime, this is y, right? Yeah. Okay, then we start for a equal to 2. Excuse me. All right, so a equal to 2, then from particular solution, the right-hand side, right? So we had guessing from the table. So a e to the 2x. So we found a, which is 2 in that case. Yeah. So there is a particular solution. So we write here, particular solution. And then we have the complementary solution here, right? Yeah. Earlier we called this as a general solution, right? Yeah. Okay, now let's do real problem in section 9.3. So we just add one more derivative. So higher derivative, right? Higher order equation. So we have that. So y to the third prime minus y to the first prime, derivative of first prime, derivative y, and 12y equal to negative 60 e to the negative 2x. Yeah. Okay, now we have an initial problem. So we're gonna find that such is C as well, right? Okay, because we have initial problems here, right? Okay, so we have experience previously, right? So that means we can rewrite characteristic equation, which is r to the third power minus 13r plus 12 equal to 0. Therefore, complementary solution, right? Okay, now we had experience as well, Desmos graph, then they give us a root, right? Okay, so there are three real number solutions, right? So -4, +1, +3. Okay, then two real distinct roots we can rewrite, but we have a 3. So we can just rewrite the 6 of 3 e to the r sub 3x. Yeah. Okay, that is the one. Okay, then we have the root -4, -4, +1, and +3 there, right? Okay, now guessing particular solution. So right hand side, g of x. So we have a, which is -60. I mean, we're gonna find a, yeah? Yeah. But this is the form. We can use guess a e to the -2x. We still can use -2 here because we don't have that -2 as a solution here, left-hand side, yeah? Okay? All right, so let's find out a. So we have particular solution of that. So y prime of, then we get, hold on one second. It's -2? It's -2, right? Yeah. -2x. All right. So y prime of particular solutions, then -2a e to the -2x, yeah? And y to the second prime, then +4a e to the -2x, yeah? Oh, we have to do one more. Third prime, because we have original has triple prime, right? So we have that. And y to the third prime. Okay, -8 a e to the -2x. Yeah. Okay, now we have original equation. Let's bring here. Copy. Okay, we substitute everything, right? So we have third prime, -8a e to the -2x. Excuse me. All right, minus 13 y prime, -2a e to the -2x. And plus 12y, which is, I don't have to make a e to the -2x equal to, right hand side we have -60 e to the -2x. So y to the third prime, y to the first prime, y. Yeah. Okay. Now we want to solve for a. Yeah. Solve for a. Okay. Let's multiply this one. So it's a, let me do everything one step more. So it's a positive 26a plus 12a e to the negative 2x equal to negative 60 e to the negative 2x, yeah? Okay, now we can combine everything. Negative a, positive 26, positive 12, right? So which is 38 e to the negative 12x equal to negative 60 e to the 2x. Okay, now solve for a. If hold on 1 second. This is a negative, right? Negative. So negative, negative. So we divide by that, that's 1, right? And we get 38 equal to negative 60, right? Then a equal to what? Negative 2, excellent. So we have the particular solution. Copy that. Then we have a equal to negative 2, so negative 2 e to the negative 2x. Yeah. Okay. Now, complementary solution we have like that, right? But then we have initial problem, so we have to find out what's the C sub 1, C sub 2, C sub 3. Yeah. Okay, I'm very sorry. This is not working. Copy. There. Okay, now. What we do, I want to add, I want to make an equation of y over x. So all together, right? So y over x equal to complementary solution plus what is called the particular solution, right? So we get complementary solution. We have that. Copy. And particular solution, right? Yeah. Okay. Now, what we are doing, so we want to find such a C sub 1, C sub 2, C sub 3, because the original equation has all the initial problems, right? Okay. Now, the previously what we did, so we want to find the derivative and second derivative because we have triple derivative in that case, right? All right, then we want to find the C sub 1, C sub 2, C sub 3. Okay, so let's do that. Y sub 1? Y sub 1? No, Y prime of X. Okay, so this one, negative 4, C sub 1. Negative 4, C sub 1 e to the negative 4x. Yeah. Okay, second term, C sub 2 e to the x plus third term, 3 C sub 3 e to the 3x. Okay, last term, positive 4 e to the negative 2x. Yeah. Okay, y, second prime of x. Okay, so we have positive 16 C sub 1 e to the negative 4x. And second term as it is. And third term, 9 C sub 3 e to the 3x. And negative 8 e to the negative 2x. Yeah. Okay, now initial value problems. So we are using that, right? Copy, paste, use. All right. Now we have y of 0. Looking at the pink here. Okay, so 6 of 1 plus 6 of 2 plus 6 of 3 minus 2. Yeah. Okay, now hold on 1 second. There's the one. And we have a right hand side. Yeah. So that's not the one, right? Hold on 1 second. Let me check. Okay, so yeah, I'm missing that. I'm missing -4. I could not find. Sorry. So we say that this is a -4. Crazy. -4. Okay. Y prime of 0. Looking at this one. So we get -4 6 of 1 plus 6 of 2 plus 3 6 of 3 plus 4. Yeah. Okay, so there will be +1. Okay, now y second prime of 0, 16 6 of 1 plus 6 of 2 plus 9 6 of 3 minus 8 equal to -49. Yeah. Okay, let us do decimals. Okay, let me find out. All right, by decimals. Okay, so we have a constant term here, right? So simplify this one. So we add 2 both sides, so we have a -2, and then we subtract 4 both sides, then we have a -3, and we add 8 both sides is we get the -41. So using decimals matrix, then I screenshot and brought here. So reduce the row echelon form. So 6 of 1, we get -1. 6 of 2, we get +2, sorry. And 6 of 3 equal to 3, right? Then I brought up the complementary solution. So we can substitute, right? So there will be 6 of 1, which is -1 e to the -4x, plus 6 of 2, which is 2 e to the x, plus 6 of 3, which is -3, right? E to the 3x, and minus 2 e to the -2x, yeah? Which is y over x. Yeah. You guys okay? All right. Then let's do one more question. Then we are done. All right. Okay. So let us do that. Solve triple derivative plus 3 y second prime minus y prime -3y and g of x right hand side 30 e to the 2x. Yeah. Okay. We have an initial value problem. All right. So let's rewrite. So we have r to the third power plus the 3r squared minus r minus just a constant, right? Equal to 0. Okay, now we have 4 terms. We can do that in the case, group factoring. So r squared, then first 2 terms, so we have r plus 3, right? And factor out with the -1, then r plus 3 as well. Then what they have in common, so r plus 3 and r squared minus 1, right? Okay, equal to 0. Now, we have r equal to -3 for first root, right? How about r squared equal to 1? There will be r equal to plus minus 1, right? Okay, they are 3 real roots, right? Okay, then particular solution we can rewrite. So c sub 1 e to the r sub 1x plus c sub 2 e to the r sub 2x plus c sub 3 e to the r sub 3x. Yeah, then c sub 1 e to the negative 3x plus c sub 2 e to the negative 1x and plus c sub 3 e to the positive x. Yeah, okay. Now, right hand side we have a e to the 2x. We can guess that for complementary solution. So guess complementary solution, which is a e to the 2x. Yeah. Okay, now we need to find the triple derivative. Yeah, so y prime over c, which is 2a e to the 2x, y second prime of complementary solution, so 4a to the 2x, y third prime of c, then 8a to the 2x. Very good. Okay, now from the original equation, we need to substitute everything, right? So let me bring up here. Oh, no. Come on. Copy. All right. Okay, so let me write down the next page. So y third prime, we have 8a e to the 2x plus 3y second prime 4a to the 2x minus y prime 2a to the 2x minus 3y, which is a to the 2x, and equal to 30 to the 2x. Yeah, so this is a y third prime. And this is a y second prime. This is a y prime. And then this is a y, right? Okay, now let me rewrite. 3 times 4, we need to calculate. So 8a to the 2x plus 12a to the 2x minus 2a to the 2x minus 3a to the 2x equal to 30 to the 2x. Yeah? Now combine everything. 8. Oops. 8, 12, 20, minus 2, 18, minus 3, 15, yeah? 15, ooh, 15 e to the 2x equal to 30 e to the, oh, missing a, yeah, 2x, sorry for a, right? Okay, then once again, we divide by e to the 2x, both sides, then it's 1. So we have 15a e to the 2x equal to 30. Oh, sorry, 15a equal to 30. And a equal to what? 2. Very good. Okay. From complementary, right? So a equal to 2. So we have 2e to the 2x. Now, we have an initial value problem, so we need to find such a c, right? So let me bring up particular solution here. So particular solution. Okay. And then we rewrite the equation of y, right? So equation of y equal to particular solution and complementary solution, right? So there will be copy and complementary solution 2e to the 2x, yeah? Okay, so let me bring the initial value problem here. Copy. Maybe later, right? Because we have to find derivative first, right? Yeah. Okay, so let's find out derivative. So negative 3 c sub 1 e to the negative 3x minus c sub 2 e to the negative x plus c sub 3 e to the x plus 4 e to the 2x. Yeah. Okay, now y second prime of x. So negative positive 9 c sub 1 e to the negative 3x positive c sub 2 e to the negative x plus as it is, right? And plus 8e to the 2x. Yeah. Okay, now use initial value problem. Okay, so looking at y of 0, so c sub 1 plus c sub 2 plus c sub 3 plus 2 equal to 0. And y prime of 0, looking at this equation, so we have negative 3 c sub 1 minus c sub 2 plus c sub 3 plus 4 equal to positive 8. And y to the second prime of 0, looking at this equation, so we have 9c sub 1 plus c sub 2 plus c sub 3 plus 8 equal to negative 18, right? Okay, let's combining like terms. So we have a constant, so subtract 2 both sides. So there will be c sub 1 plus c sub 2 plus c sub 3 equal to negative 2. and negative c sub 1 plus negative c sub 2 plus c sub 3, negative 4, which is positive 4, and 9 c sub 1 plus c sub 2 plus c sub 3 equal to negative 8, so negative 26. Yeah. Okay, so let me pause and then I'm gonna do decimals. Yeah. Okay, so we got this one, right? And then using decimals, so I have c sub 1 equal to negative 3 and c sub 2 equal to positive 3 and c sub 3 equal to negative 2. So we have the equation. So particular solution, we substitute all the the constant term, right? So let me write down. So y over x equal to c sub 1 negative 3 e to the negative 3x plus c sub 2, which is 3 e to the negative x, c sub 3, which is negative 2. So plus, no, negative, I just said negative. Negative 2 e to the negative x. Sorry, I missed so. Yeah. X and plus the last term from the complementary solution, right? So 2e to the 2x. Yeah. Okay, thank you for watching. Bye.